Nonlinear climate response to tropical sea surface temperatures, all you need to know. Nonlinear climate response refers to the phenomenon where a small change in one aspect of the climate system can result in a much larger, non-proportional impact on other aspects. One area where this has been observed is in relation to tropical sea surface temperatures, SSTS. The relationship between SST and global temperature is generally considered linear, meaning that a rise in SST should lead to an equivalent rise in global temperature. However, studies have shown that this relationship becomes nonlinear above certain thresholds. One consequence of this nonlinearity is that even small increases in SST above these thresholds could trigger disproportionate changes elsewhere in the climate system. For example, it has been suggested that such changes could lead to more severe El Niño events, which can have major impacts on weather patterns around the world. Nonlinear responses like this are difficult to predict and model accurately, but understanding them will be important for developing effective strategies and adapting to future climate change. Further research will be needed to fully understand these phenomena and their implications for our planet's future. What are the potential impacts of a nonlinear climate response to tropical sea surface temperatures? A nonlinear climate response to tropical sea surface temperatures is a complex phenomenon that can have significant impacts on the Earth's climate system. One potential impact is the amplification of extreme weather events such as hurricanes, typhoons, and cyclones. As tropical sea surface temperatures increase, these storms become more intense and destructive. Another potential impact is the disruption of ocean currents, which play a critical role in regulating the Earth's climate. A nonlinear response could cause changes in ocean circulation patterns that could affect temperature and precipitation patterns on a global scale. This could lead to droughts or floods in certain regions or even trigger abrupt climate change. In addition to these impacts, a nonlinear response could also exacerbate existing environmental problems such as sea level rise and coral bleaching. Rising sea levels due to melting ice caps combined with more intense storms could cause widespread flooding and erosion along coastlines. Meanwhile, coral reefs are already under stress from warmer waters and increased acidity, but a nonlinear response could push them past their tipping point towards collapse. What is the current understanding of the nonlinear climate response to tropical sea surface temperatures? The nonlinear climate response to tropical sea surface temperatures is a topic of great interest in the scientific community. It is widely understood that the atmosphere and oceans are closely linked, and changes in one can have significant impacts on the other. However, it has become increasingly clear that this relationship is not always straightforward. What future research is needed? The nonlinear climate response to tropical sea surface temperatures is an area of growing interest and concern for climate scientists. Future research should focus on developing more accurate and precise models that can better simulate the complex interactions between the atmosphere and oceans. Conclusion. In conclusion, the nonlinear climate response to tropical sea surface temperatures is a complex phenomenon that requires further investigation.